maximum.
조선민주주의인민공화국 핵무기연구소 상명 대륙간 탄도로켓 장착용 수소탄 시험에서 완전 성공. 대륙간 탄도로켓 장착용 수소탄 시험이 성과적으로 진행된 것과 관련하여 조선노동당 중앙위원회는 북부 핵시험장에 우리 핵과학자 기술자들에게 뜨거운 축하를 보내어 왔다.
Hello, everyone. Thank you.
Okay.
Is there anyone here who doesn't know this lady? I don't think so. Her name is Recon, and she's like the national official presenter of North Korea. And kudos to her, of course, for this emotional introduction to our talk. So our talk's title is, as you can see, SiliVaccine, North Korea's weapon of mass detection. So there's going to be a talk here about North Korea and about something called SiliVaccine. We're going to understand a little bit what that means in a second. But before we do so, let me shortly introduce ourselves. So that's us. That's actually, these are our Twitter handles. You can follow us. That's actually not Seth Rogen. That's me. My name is Mark Lechtik, and I'm here today with my friend and colleague Michael Kajilotti.
Hi.
And we both, other than being capitalist pigs, work as researchers for Checkpoint. And before we actually dive into the topic of research itself, I would like to shortly introduce to you how we got into this research. So how did it all begin? So our story begins with one evening, I'm going through Twitter and I stumble upon the following article you see on the screen called Inside North Korea's Hacker Army, which is quite an interesting piece about a North Korean defector who used to work for a government agency as a hacker. And like reading through the story, I sort of notice a narrative of this cyber operations taken by North Korea. And in one particular paragraph, you can see North Korea's official response on the allegations made by the West regarding them hacking. So I quote, "Formally, North Korea denies engaging in hacking and describes accusations to that effect as enemy propaganda. It says its overseas computer efforts are directed at promoting its antivirus software in the global market. The country has for more than a decade been working on such programs, including one called SiliVaccine." Now, what is SiliVaccine? Well, as you may understand by now, that's an antivirus developed in North Korea, so a North Korean antivirus, or how we like to refer to it, the Kim Jong-un T-virus. And as you may guess, this is quite a rare software. You can't find it outside the DPRK. It's not something that you can download on the internet. As far as we can tell, this thing was developed since around 2003. And the version we are going to focus on is 4.0, which was released in 2013. As a matter of fact, we are also in possession of another version which was released in 2005. That's the first version of SiliVaccine, and we'll refer to it from time to time. So, if you know North Korea, you should be able to tell that most citizens there don't have access to the internet. That's a well-known fact. Instead, they have what's called an intranet, a state-governed intranet, which is referred to as the Kwangmyong, and it has strictly controlled content. And if that's the case, why would they need an antivirus? So there are quite a few explanations for this, as a matter of fact. For instance, it turns out that the North Koreans are quite afraid of smuggled media. And evidence for that is a phenomenon of USB sticks that somehow find their way inside North Korea. And if you smuggled USB sticks, and if you think that's fucked up, which is fine because that's North Korea we're talking about, then you can check out the following website called Flash Drives for Freedom, which is this crowdsource funding thing for smuggled USBs. And they get inside North Korea. I shit you not. Fun caveats: if you have problems with the IRS and you want to donate a USB, you'll get a tax refund. So don't worry. Also, what is in those drives? So it turns out stuff that range from Wikipedia articles to South Korean soap operas, which is like evidently a threat. But anyways, this is one thing the North Koreans are afraid of. Another explanation as to why this AV exists is to actually sell this product on the worldwide market. So that was actually stated by North Korea itself. But to corroborate this fact, we can say that the 2005 version that we own was actually written both in English and Korean, which may suggest that this product was initially designed to appeal to as a commercial product for people outside North Korea. So what did we have in mind when we started to research this thing? So, before we talk about this, how did we obtain it? That's the question you must be asking yourself. So how did we obtain this antivirus? So the answer to this lies in the Bloomberg article we just saw a moment ago, which linked to a blog post by a guy named Martin Williams. Now, Martin Williams is an independent journalist who covers various news items related to North Korea. And he got it through the following email from a guy naming himself Kang Yong-hak from Japan. And he got it through what seems to be quite a fishy email. Keep that one in mind because we'll refer to it later on. And of course, Martin agreed to share it with us for deeper analysis, and that's the place to thank him because this research wouldn't be possible without him. So, what did we have in mind when we started doing this research? So, first of all, we wanted to understand how this program is built. What is its architecture? Through which we really hope to observe or get our sort of anthropological view on practices taken by North Korean engineers, meaning how would engineers with restricted resources would tackle a complicated problem like building an AV from scratch. Obviously, we want to find any kind of hidden mechanisms that could be put in place deliberately by the authors, and in particular, anything that could serve as a backdoor for the government so as to spy on its citizens. So with that in mind, let's start looking at the first item in that list, which is the antivirus's architecture. And we'll do so as we have some common grounds, some kind of notion of the components that comprise this antivirus. So first of all, we have the software libraries, a bunch of DLLs which are used by the AV. The first of which is called SV Shell, which is a basic shell extension, adding this entry you see right here to the context menu handler, which is actually intended in order to allow the user to scan files manually. And you know what? Let's just see for ourselves how this works. So we have this virus we're trying to scan with this feature. We set it in motion, and nothing happens. Which is, right from the very beginning, we can see that there are problems with this antivirus, but this seems like just a feature that, went buggy, so, what the hell. Next component we're going to talk about is svkernel. Now, svkernel is the file scanning engine of the software. This is the core component that is in charge of scanning files on the system and determining whether they are malicious or not. If we look at the DLL itself, it contains like 20 export functions with the ambiguous names svfunc001 through svfunc020. If you're, looking for a bad naming convention, then here it is. The verdict is obviously based on the logic that is constituted by this DLL and also by a bunch of signature files that also exist in this AV. Third component is just meant to deploy other components of this AV on the system. We won't discuss it very much, it's not very interesting. Next group of components are the GUI components, which are for the most part pretty self-explanatory. So we have one called svtray.exe, which is obviously this small tray menu that you see on the right bottom of the screen, which enables you to execute other GUI components. An example of one such component is svmain, which is like the main GUI component through which you can scan files on the system. You can, play around with some configurations. You can whitelist some files. You can blacklist other files. And essentially, this is just like a one-stop shop for all the antivirus's features. This component actually loads a driver called svhook.sys, which is intended to deliver some information on processes from the kernel space. We'll discuss this driver a little bit later, so keep this one in mind. So another component we have here is actually the update utility, svupdate, which, as the name suggests, just downloads binaries or signatures from a server, and it will deploy them on the machine, and will then check them with another auxiliary component called svdiff_update.exe, which is just a simple integrity checker. So, as I mentioned at the very beginning, North Korea does not have internet for the most part. So, it is obvious that this component would have to communicate to a server within the DPRK. Now, this communication will happen through a custom update protocol working on top of HTTP. And we can see an example of some of the messages passed on this protocol right here. But what I'd really like you to notice is the vast amount of information which is being passed through these messages, which contains stuff like the serial number, interface ID, IP, and whatnot, which for the most part is pretty suspicious. But as we don't have access to the actual North Korean server, it's really hard for us to tell why they collect this information. So we'll just leave it as a speculation that they have some internal reasons to collect it. And also what I'd like to say about this protocol is that there are some peculiarities in its implementation. So for one, we can see that, for instance, the content length field of the HTTP header appears with an underscore here, when it obviously should appear with a dash, which is a mistake. And also, this utility is supposed to convey its identity to the server through a user agent, only instead of modifying the user agent string, they append another field to the HTTP header called user dealer, which I don't know what kind of dealer they had in mind here, but it has nothing to do with HTTP, obviously. And speaking of dealers, we have another component here called svdealer. Now, svdealer is, in fact, a real-time scanning component. So this is basically just a component that intercepts communication or interaction between the user and the file system. And it would conduct a scan of files before actually executing them, so as to avoid execution of malware in runtime. And for that, it would leverage a driver called svfilter.sys. This is a file system filter driver, which we will also discuss a little bit later. Now, at this point, I should mention that the two components that actually issue scan tasks here are svdealer and svmain, which would obviously have to load svkernel for that. But as a matter of fact, in order to conduct a successful scan, they would have to load some kind of signatures. These will reside in a bunch of .spf files, which we'll refer to as the pattern files. And they constitute the malware signature database of this antivirus. Another component we can see here in the kernel space is actually ststdi2.sys, which is a TDI network filter driver. Now, if you don't know what I just said, although I imagine a lot of you do understand, it's fine, because this component, actually what it does is Well, absolutely nothing. This component is supposed to intercept communication and by TCP TDI clients and register it in some internal structure, and then another entity would be able to query it, but unfortunately no component, this antivirus, ever queries this driver, so it just sits there idle, doing nothing. Well, another noteworthy thing is that most of the components here were packed with Themida. As you may understand, that's a pretty vicious packer for reverse engineering. Luckily for us, the authors of this software did not enable particularly, I would say, vicious features on their own. So it was, moderately easy for us to unpack most of the binaries here. And this is like the full architecture of this whole thing. And it's kind of convoluted. But what I'd really like you to notice is the component that we already spoke about, which is svkernel.dll, which I remind you is the file scanning engine of this software, which is why we're going to talk about it next. And here's where it gets interesting. And we'll begin the discussion of this component by looking at what every good reverse engineer looks at. Strings. And these are the strings that we stumbled upon when we opened the binary. And obviously, like every good reverse engineer, we Googled them. And much to our surprise, it brought us to another publicly available file called vsapi32.dll. Now, what is vsapi32.dll? Well, it turns out to be another file scanning engine. But not just another file scanning engine. It's a file scanning engine belonging to Trend Micro, which was quite a surprising revelation. I understand Trend Micro are sponsors here, so hello, guys. So it really begs the question, did the SiliVaccine authors actually use this component from Trend Micro as is, or did they in some way integrate it into their own product? Well, let's find out. So, in order to do so, we conducted a binary diff between the two engines. And here on the left, you can see the Trend Micro functions. Yeah. And on the right, you can see SiliVaccine functions. And you can witness yourselves that there's like a 100% match on more than 1,000 functions between those two engines. As a matter of fact, there are some export functions that have like a particularly exact match. And those three you see on the screen are not the only ones. Actually, all first 18 functions from SiliVaccine map to some functions by Trend Micro's engine. And to just convey that, let's take a look at 3 pairs of such functions and look at their call flow graphs. And we can see that really for the most part, they are pretty similar. But I would say that it's more interesting to actually look at the small nuances or the small differences in those pairs of functions. So for example, let's take the following pair, where we have a function called vsinit and svfunc005. And vsinit is just basically a function that's supposed to initialize a scan with a struct. It should initialize a struct before a scan. And what I'd like you to notice here is the following thing. While vsinit uses the libc memset function, svfunc005 uses an inline implementation of it, which really might suggest the fact that the authors of SiliVaccine had some access to proprietary resources that enabled them to recompile this particular function with some compiler optimizations that were not resident in Trend Micro's code. We can see another example for this in the memcopy function and qmemcopy, which is its inline version. And let's take a look at another example, which is this pair of functions. And we have vsGetVSCInfo, which is a function that's meant to initialize some metadata about the engine itself in a memory struct. And again, we can see some function inlining here, but what's more interesting is actually the fact that this function places a hard-coded string containing the engine's version in the struct. So we can see that the version used by SiliVaccine is actually 8.910, which we know was released in 2008. And remember that this product was released in 2013. So they were basically using a 5-year-old engine in their software. Finally, let's take a look at another pair where we have VSQuit and svfunc006. And VSQuit is basically a cleanup function that's supposed to clean some resources from memory when a scan task is completed. And what we can notice here is that, as a matter of fact, the SiliVaccine version of it contains a call to a function I called SVIO driver cleanup. Now, SVIO is actually a legacy driver that was used by SiliVaccine. It has nothing to do with Trend Micro. And again, we can see that it appears in line within a function that was originally written by Trend Micro, which, to me, at least, suggests that there could have been some kind of recompilation here. Another thing I should notice here is the 2005 version of SiliVaccine we initially mentioned. So it turns out that this version also had some Trend Micro code in it. As a matter of fact, it used another component by Trend Micro called tmfilter.sys, which is the kernel mode equivalent of Trend Micro scan engine. And it really serves to show that what we see here, this copyright infringement, was not a one-time thing, and it was possibly going on for about 8 years. At this point, I would like to address Trend Micro's response to this. I should say that they were very responsive and very cooperative. This is their official statement. I'm not going to go over all of it, but just to kind of mention the important parts. So Trend Micro basically says they confirm that their engine was used in SiliVaccine. They also say that they have never done any business with North Korea, and they don't really know how their engine ended up in North Korea. Another thing that they did suggest that it was possible that this component leaked somehow through a third party, which worked with them as them being the OEM. We can't actually verify that, so I don't know. But anyways, other than this being like a very secretive software, I could say that it's really difficult to find Trend Micro's engine within SiliVaccine, because there are quite a few mechanisms in place used in order to conceal it. And you know what? I'll let Michael tell you a little bit more about it.
Thank you, Mark. Hi, everyone. So we essentially just realized that SiliVaccine is using Trend Micro's engine, and we were wondering if it's using the same engine, does it mean it's also using the same signatures? Well, if we compare on the surface, they look quite different. You can see SiliVaccine uses multiple small pattern files, while Trend Micro uses a single large pattern file. And when we open them up to do a basic comparison, we see no similarity in structures, structure, strings, or any kind of other similarities. So we looked a bit deeper, and we found the place in the code where the pattern files of SiliVaccine are actually loaded. And it happens in one of the exports of SV kernel. And here we can see that the pattern file name is being constructed, and then a handle is created to that file. The contents of that file are read, and then it's sent to some kind of decryption function. And after the decryption, that data is appended to a global buffer in memory, the ID of the pattern file is incremented, and then the whole process repeats. So what we're seeing here is a function that loads all of SiliVaccine pattern files one by one, decrypts them, and appends them to a global buffer in memory. And before we talk about the decryption or encryption itself, let's talk about the encryption key for a second. So here is the encryption key. You can see it looks pretty random. And we were wondering if this string means anything in Korean. And turns out it doesn't mean anything in Korean. But an interesting thing happens if we take this string to an English-Korean keyboard. and try to type it while the language is set to Korean, we'll get the following string. And if we translate it back to English, turns out it literally means pattern encryption. So that's the key. Now, regarding the encryption itself, we didn't bother really understanding it. Here you can see SHA-1. You can see a lot of encryptioning going on. And really, we realized this is some kind of custom encryption. But we weren't interested in encryption itself. We just wanted the decrypted pattern files. So we simply dumped them from memory. Now, when we compare them after decryption, suddenly they look quite similar. You can see that they have a very similar header. And if we scroll down a bit, we can see the same exact strings. As a matter of fact, it's 90% match of strings. And so basically, we think the difference is because we don't have the exact same version. So yeah, essentially, SiliVaccine is using Trend Micro's pattern files, which is not surprising. And here we can see some of Trend Micro's, lovely names like Trivial O and Surrender E and DJ Virus, which is, we thought it's pretty fun. So now we decided to test this. So we took a bunch of files and we scanned them with both engines. So they were all detected by SiliVaccine, and they were also all detected by Trend Micro, not surprising here. But what is surprising is that we saw a difference in the detection names, which is weird because they're using the same strings. This is, I would say, suspicious. So we found out actually what's happening is that SiliVaccine is renaming the signatures before displaying them to the user. And here is how the renaming works. We can take an example here. This is a Trend Micro signature name. What SiliVaccine does, it copies that. It breaks it down by removing the dashes and underscores. And then it replaces the prefix. So Troj is replaced with TRJ. It then replaces with the suffix as well. So a number is replaced with a letter. And then the casing is modified for the rest of the signature. And everything is put together with dots. And now you have a SiliVaccine signature. So here's a table to show you the translation between Trend Micro's prefixes and SiliVaccine's prefixes. And here's the same one for suffixes. You can see nothing really special here. But what does it all mean? Well, we think, we can say that what it means is that SiliVaccine authors are trying to hide the fact that they're using Trend Micro's engine, which is not surprising. So you can see that the binary files are protected with Themida, so you can't see any strings in the binary files. The pattern files are encrypted, so you can't see any strings there either. And the malware signatures are renamed before being displayed to the user. So actually you have, as a user, or even as a researcher, if you don't dig too far inside, you can't see really any clues about this thing going on. Moving on to some of the fishy things that are happening inside the engine. During our analysis, we saw in many of SiliVaccine's binary files, we saw this string, which is mal_nucryp_f. Now, we understood that this is probably a renamed SiliVaccine signature. But the question is, what was the original signature? What was the Trend Micro signature that was renamed? So let's run this algorithm in reverse and get to the signature. So we copy it, we replace the prefix back, we replace the suffix, and we get mal_nucryp_5. But what is going on with this string or with this signature? Well, here are two instances where this string is referenced, both in functions responsible for file scanning. One is in svmain and the other is in svdealer. And we can see a file is being scanned. And then there is an explicit check to see if the file was detected to be malicious and if the detection name specifically is mal_nucryp_f. And if that's the case, well, this is simply ignored. So this is suspicious. Actually, what's happening here is it seems like they're whitelisting this signature. So we decided to test it. We took 6 files that are detected by Trend Micro as mal_nucryp_f. Of course, they're all detected. And we scanned them with SiliVaccine. And nothing was detected. So the whitelisting works. It actually should not be taken for granted, because when we did some QA on the whitelisting that they did, we can see that it's mostly okay, but in one of the instances, they actually misspelled what they're trying to whitelist. Now, fortunately for them, this instance is redundant, so it doesn't matter. Now, the question that you're all asking, so what is NuCrypt? What is whitelisted here? Well, according to Trend Micro's encyclopedia, which is a thing, if we look it up, we can see that malNuCrypt5 is a signature related to some old malware, which actually have no relation to North Korea. But if we dig a bit deeper and look at the name itself, we can see that the mal prefix indicates that this signature is some kind of a generic detection name. Now, while it was created based on some malware, it actually detects much more than it was intended to or was built upon. So we can't really know which malware, or even if it was a malware, that they're trying to whitelist here. But we can speculate on some, like, why are they doing it? So most possibly, this is some kind of an existing tool that already is installed in North Korean computers, and they don't want it to be detected. Now, it's also possible that they want the option to build such a tool and actually design it to match this signature, so essentially not be detected at all. Now, since they took a third-party engine and they're using it mostly as is, it's possible that that engine, Trend Micro's engine, detected one of SiliVaccine's own component as this malware or this signature, and they whitelisted it. It's also possible that this is a false positive management on behalf of SiliVaccine's authors, but we really don't think so, because this is the only case where it happens, and the signature is fine. Now, moving on to the next section, let's talk a bit about the kernel side of SiliVaccine. So, as we said before, SiliVaccine uses 3 drivers. We said that STS-TDI2 is not used at all, so we're not going to talk about it. Instead, let's focus on the 2 drivers that are used, which is svfilter and svhook. Now, when you start analyzing it, you see quickly that there is something going on. There seems to be some kind of custom protection used here. You can see that the address of entry point is in the relog section, which is weird. And you can see that the packer, it seems to be packed with something called bobcrypt, which is suspicious. We never heard of bobcrypt, but apparently it exists. And this is some old Russian packer. You can see by the Windows version that they're supposing that this is pretty old. And it's supposed to be some kind of packer with features such as anti-debug and polymorphic code. And at this stage, we thought, wait a second, maybe we're missing something. And we got back and we looked at the file again. We looked at the file itself again and thought maybe we can find the answer there. And we actually found our answer, and it might surprise you, but the answer is 42. Like really, 42. You can see that the text section is simply XORed with 42. And 42 is the answer for everything, so I don't know why we were surprised to begin with, but, well, to be fair, it's 42 hex, but you know, still. So after we opened this packer, or whatever you want to call it, we can look inside the drivers. And we can see that the first driver, svfilter.sys, as we said before, it's a file system filter driver. It's loaded and utilized by svdealer, which is the real-time scanning component. And it has actually 2 main functionalities. It's responsible for intercepting file access, so to allow the real-time scanning. And it protects the AV binaries themselves. So when you look inside svfilter, you see that it's actually it seems pretty complex. And you see a lot of spaghetti code. And it took us quite some time to realize that this is the only 2 things that it's doing. So I'm going to save you some time and show you how it works in a nutshell. So it starts by actually wasting some time doing redundant checks that don't really amount to anything. Then it moves to check if the file that is being intercepted is an AV binary. And if that's the case and the process that is accessing that file is not part of the AV, the access is denied. So it protects the AV binaries. It then moves to waste a lot more time doing, again, things that don't make any sense. I don't know why it does that. It doesn't seem like obfuscation. It's just random checks. And then it scans the file with the real-time component. So it signals the SV dealer to do a scan, and then it checks if the file was detected to be malicious. And if that's the case, then, again, the access is denied. Otherwise, the access is allowed. And this is SV filter in a nutshell. Moving on to the next one, SV hook. Now, it's loaded and utilized by SV main, which is the main GUI component. And contrary to its name, it doesn't hook anything. Instead, it's used to query object metadata from the kernel. So SV main uses it to get data from the kernel while it's doing a memory scan. Really, again, it is really, really odd and confusing, even more than SV filter. It contains a lot of code that is never utilized, and it's very buggy. So for instance, I said that SV main and SV hook work together, but it really seems like the two components were developed by entirely two different developers. So here we can see that the developer of SV main is programming SV main to use one of SV hook's ioctl with a buffer size of 12. So you would assume that the developers have agreed that the buffer size should be 12. Unfortunately, there seems to have been some kind of misunderstanding, and the second developer performs an explicit check to see if the buffer size is 12 and return an error. So it doesn't work. This thing doesn't work at all. And I think after looking a bit deeper, we may have a possible explanation on why SV hook seems so, I would say, out of place. When we looked a bit deeper, we found a lot of this. Now, I think you can see what this is. These are debug prints referencing to the function that is being debugged by an ITA auto-generated name. So essentially, it seems like we were reverse engineering a reverse-engineered driver. So what happened is that somebody took another driver, decompiled it, and copied it to make SV hook, and added these debug prints to try to understand what he was copying. He forgot to remove it, and I don't think he actually understood what he was copying, according to our analysis. Now, we talked a lot about SiliVaccine, but I think to get the full picture, it's a good idea to look at the development story behind SiliVaccine. And I'll let Mark tell you more about it.
Thank you, Michael. So who is behind SiliVaccine? In order to answer this question, we refrain to some of the version info that resides within those binaries. And we stumbled upon a few companies there. One is called PGI, which stands for, excuse my Korean, Pyongyang Gwangmyong Information Technology, which is actually a known research center in North Korea. It did appear as an author of other products that come from North Korea. And it basically specializes in network security. It's not a very interesting company on its own. Another one that we stumbled upon is called STS Tech Service. Now, this one is actually quite of a mystery because there's no trace of this company's activity online. They don't have any website. They don't have anything to show what they do. So they're basically a ghost company. But what do we know about STS Tech Service? So for one, we can say that they are based in the DPRK. And actually, our reason to believe so is this brochure you see here on the screen. That's actually an invitation to an exhibition that took place in Pyongyang around 2005. And you can see that one of the participating companies was STS Tech Service. Now, we contacted the organizers of this exhibition, and they actually confirmed that STS Tech Service came from the North Korean side. Still, there are a few questions. Is this a private company in North Korea? Is that a government entity? Maybe that's the same thing. I don't know. We can't tell. Also, we had one source that mentioned that this might be a subdivision of the KPA, where the KPA is Korea People's Army. We don't have any way to verify it, so we can just leave it as a speculation. And if you recall, I mentioned before that Trend Micro suspects that their engines somehow leaked through a third party. Now, could STS Tech Service be involved in any way to this leak? So actually, we don't know that, but what we did see is a very, I would say, overwhelming connection between North Korea and Japan. And one connection we already saw, that's between SV kernel and Trend Micro's engine. But we did stumble upon a few other interesting connections. One is, for instance, this following software here, which was developed by STS Tech Service and another Japanese company called SilverStar. We could also see such a cooperation between STS Tech Service and another Japanese company called Magnolia. And if you look those two Japanese companies up, you can actually see that they reside within the same address in Tokyo, which is, I don't know, weird. Also, all three companies here, STS Tech Service, SilverStar, and Magnolia, at some point cooperated on another application, it seems to be, with the KCC. KCC is a Korea Computer Center. That's a very well-known research establishment in the DPRK. And, it's looking at this, it's very easy to, get drawn to some kind of speculations because, North Korea and Japan are not friends, to say the least. But you should remember that what we're seeing here is just a crazy web of connections. I mean, other than pointing out those kind of connections between the companies themselves, we can't say much. But we did see some kind of malicious intent within the software, and I'll let Michael tell you a little bit about this.
Okay, so at this point in the research, we were satisfied. We thought we were done with the research. We found a few interesting things. But then we said, wait a second. This is North Korea we're talking about, and we didn't actually find any backdoor or any malware in this whole thing. So while we found the malware whitelisting, yeah, it's possible, but we didn't find anything substantial. So does it mean there is nothing here? We thought we'll go back and examine to how we actually received SiliVaccine. And if you remember, we received it from Martin Williams, who in turn received it via this email, which looks pretty suspicious. An anonymous email claiming to be from a computer engineer in Japan named Kang Yong-hak. Now, an interesting thing, a famous Yong-hak is An Yong-hak, which is a North Korean footballer born in Japan. So again, all these crazy connections to Japan. What does it all mean? We have no idea. So going back to the email itself, we thought we'll examine the package. So we took a look at the package. So what happened when we received SiliVaccine, we simply installed it and started analyzing it. And we never looked at the installer itself, silly us. So here is the installation file. When we look at it, actually, it turns out this is a self-extracting WinRAR archive that contains another installation file of SiliVaccine, which seems to be the real installation file, like from the metadata, and something claiming to be a patch file. But we quickly understood that something was off when we looked at the metadata, and supposedly this patch file comes from Microsoft, and it's related to automatic updates. Yeah, I don't think so. So this is very suspicious. Examining a bit deeper, we saw that this file is signed, and the certificate that was used to sign it was issued to some company that if you Google it, you quickly find out that almost the exact same certificate was used in the Dark Hotel APT. And this is really, really suspicious. So we analyzed this malware, and we understood that what it does, it collects basic information about your computer and sends it to a remote server, which was down. And when we looked up this exact sequence of commands, we found out that this is actually the stage 1 malware in the Jaku botnet campaign, which was uncovered by Forcepoint in 2016. And further analysis confirmed that this is actually Jaku. Now, what is Jaku? Well, it was an ongoing botnet campaign that targeted Korea and Japan. And while it infected a lot of computers, a lot of victims, turns out that the later stages were intended only for a select group of individuals, with North Korea and Pyongyang being the common theme between those individuals. Another interesting thing pointed out in the Jaku report was that the connection between Jaku and Dark Hotel. And in our case, the certificate that was used to sign the Jaku malware, we can say is another such connection. So what's happening here? Well, we think that this whole thing was simply a spear phishing attempt at Martin Williams, who is a journalist covering North Korean technology. And everything matches up to it, because it seems like Martin Williams was simply another target of the Jaku campaign. It's also possible, though, that Jaku is bundled with SiliVaccine every time. We don't know that. We have no way of knowing what the citizens themselves are installing. But we think that this was intended for Martin. Now, you might be asking yourself, wait a second. We talked about malware whitelisting, and we just found malware, right? And we thought, wait a second, is this the whitelisted malware? So we scanned it with SiliVaccine, and it was not detected. So we were very excited. But then we scanned it with Trend Micro, and it was also not detected, and with other AVs, and it was also not detected. So it seems like it was not detected because there was no matching signature. And this has nothing to do with the whitelisting. So we don't know what the whitelisted malware is. Well, we told you basically everything, but before we finish, I think it's a good idea to summarize it. To summarize everything up and look at the conclusions and the things that we don't know for sure yet, or the open questions. So I think we can say that the main conclusion is that SiliVaccine has been illegally incorporating proprietary Trend Micro components inside its product for years, over multiple different versions. And we're talking about different components as well. Obviously, they tried very hard, or I don't know how hard, but they tried to hide this fact. We also saw that SiliVaccine explicitly whitelists a very specific signature. And we also saw that the installation file comes bundled with the Jaku malware. However, there are some things we don't know. Right, so the things we don't know, well, there are quite a few, as you may understand. So first of all, we can't tell in what way did the SiliVaccine authors were able to access any kind of Trend Micro proprietary resources, and whether they did so at all. Also, we saw that malware that was whitelisted, or signature that was whitelisted. What is it? Is it malware? Is there any particular reason that it's whitelisted? We can't answer this question, unfortunately. And also, we've seen the Jaku malware that was bundled as part of the installation package. And again, since we don't have access to the software and the way it is downloaded within the DPRK, it's hard for us to tell whether it's bundled with every version of SiliVaccine, or was it only attached to the copy that was sent to Martin Williams. And we really prefer to leave these questions to the research community. And although we can't provide any clear and concise answers to everything, what we can say is that there is a theme that repeats itself throughout this research. And that's a theme of fraud, of shady practices, copyright infringements, everything that is actually meant to develop a software that in a perfect world could have been totally legitimate. And with that in mind,
I would like to thank you for your attention, and I hope you enjoyed the rest of Recon.
Was Dropbox of any help of getting more intelligence about that sample, where it came from, who else it might have been shared with, and who else might have been targets?
Yeah, we actually contacted Dropbox. They said that this directory is no longer, I mean, it does exist. It was accessed like one time, like 4 years ago or so. And basically, they can't say much about who owns it.
Right. Do you have any speculation as to why they would have explicitly whitelisted something that they're clearly the unique providers of the signatures they're providing? If they're encrypted, albeit not very securely, are they expecting? Do you think they're expecting other people to be providing their own list of signatures, or do you think that's some kind of automatic update rollout that they're preparing for? It doesn't seem to make sense to me.
Can you repeat the question?
So the whitelisted signature is a signature, if I understood correctly, that the same people who wrote the malware are providing. If that's the case, why don't they just delete the signature? Why are they providing a signature that they're whitelisting?
Okay, good question. They are not, as I said in the presentation, the signature was not intended to catch a specific malware. What we think happened, if anything happened here, if they're not playing games and they're actually whitelisting something, simply they scanned their whole system with this antivirus, because they're actually using a third-party engine, right? So they scanned their system or their image, and they saw that this signature pops up. So it detects something, either it's malicious or not. Whether it's malicious or not, whether it's some kind of spying tool or whether it's some kind of homebrew software that North Korea is using, and they said, okay, this is off. And another interesting thing is they're using whitelisting at the code level, right? Because they don't really understand. It's very hard to remove, individual signatures from the pattern files, and they would have to do it at every time. So they're simply using Trend Micro's engine and Trend Micro's pattern files, but they're whitelisting it externally. So the whitelisting will work no matter what.
Hey guys.
Hey.
Great work, by the way.
Thank you.
That's a super cool find, and a lot of patience to reverse that. A lot of us kind of saw the report come along and just kind of waved it by and let you guys do everything. But I was actually really curious. I didn't see any IOCs. Are you guys willing to share hashes and stuff from the report? And it's not just like it's not a broad question about it. It's just given the Jakku Dark Hotel connection on the SV patch file. There's been a lot of back and forth between North Korean malware and Dark Hotel, which presumably most of the time is actually considered a South Korean connection more than North Korean. So it's quite interesting to see the possibility that this is another one of these operations that Dark Hotel seems to be running to map the intranet in North Korea, or whether it is the North Koreans spying on themselves. But it would be great to just take a look at the malware file if you guys are willing to.
Yeah, sure. We have no problem with updating the IOCs. It's a good remark. Thank you.
Oh, no problem.
Any more questions?
Oh,
There's one more.
Hi, it's an awesome analysis.
Bruce.
Can you when you were doing analysis of this stuff, do you hit any like blue screens with their engine? And also, like, can you make a comment about the quality of their code compared with the Dark Hotel components? Because the Dark Hotel component, they have several kernel mode components which are actually like fairly sophisticated, but compared to what like the people who wrote this vaccine thingy, like, it looks kind of.
Well, the quality of the code, in short, is shit. I'm sorry. So I cannot like attribute this to the Dark Hotel authors, obviously. But regarding what you said about BSODs, we didn't stumble upon those. We did run it on pretty old boxes. So I guess if you load it on Windows 10, then you know all hell breaks loose probably. So yeah.
Another thing I would mention is that we really think that the JACO is separate from the SiliVaccine itself in all related matters. Like JACO is much more professional. It has no similarity in code, in structure. We think that SiliVaccine is simply SiliVaccine, the Sili antivirus software that it is. And JACO is a serious operation with a very high quality malware. It actually took us time to realize, even with all the, the red flags that this JACO malware has, it's not really behaving like malware. It's not deleting itself once you execute it. It has, when you open it up in IDA, it seems, I don't know, it's doing stuff, but you can't see really that everything is very hidden, but not in a suspicious way. So it takes you time to, not a lot of time, but it takes you some time to realize that this is malware.
Hey guys.
Hey.
Are all North Korean users of the intranet required to use SiliVaccine?
Not as far as I can tell. Obviously, we don't know that. I mean, it's not public knowledge. They did add like a text describing the software, like it was bundled with the installation. And they did recommend like people who work at academic positions to install this software for some reason. But otherwise, we don't know if like all citizens are required to install it on their machine.
Thank you.
Were there any callback mechanisms, update mechanisms like DNS names that you might have been able to poison on the internet to see if there were any in the wild instances on the internet?
So it doesn't connect to the internet. It connects to the intranet. So it actually doesn't.
This is a DNS lookup, even if it was valid on the intranet. If you poisoned that,
It's going to an IP, an internal IP.
Yeah.
If not, thank the speaker again.
Thank you.
Thank you.